Well, good afternoon, my sixth grade friends, soon to be seventh graders. This is the second lesson of the last official sixth grade chapter, and it's entitled Box Plots. How can you use box plots to display data? So this is just another way of displaying data, much like the histogram, the dot plot, and bar graphs you've done in the past, line graphs. So the box plot is just another way to display the data that we're talking about. Okay, so before we get started, I just want you to absorb a couple of things I'm going to say. Box plots help visualize the variability of data. Base word of variability is variable. So to tell how the data varies. The variability, or how it varies, of the data describes how spread out it is. So on your box plot, the longer the box, the more varied the data. If the box is short compared to the whole plot, the data values are more concentrated and less varied. So to make a box plot, you'll use the least value, the greatest value, the median of the data, the lower quartile, the upper quartile, okay? And then the median we know is the data value in the center of the data. It divides the data basically into two halves. Okay, so we're going to be using a lot of vocabulary words. They're big words, but don't be afraid. They're pretty simple if you just pay attention. All right, so the median is the middle value, which we know, or the mean of the two middle values, because if you have an even set of data, you need to take the mean of the two middles to get the median. When data is written in order, this is the key thing for median. The lower quartile is the median of the lower half of the data set, and the upper quartile is the median of the upper half of a data set. So let's take a look at that. In 1885, a pair of jeans cost $1.50. Did you hear that? Are you paying attention? Today, the cost of jeans varies greatly. I do know that because there are a lot of jeans in these higher end stores that are like over $100, but then you can go to Old Navy and get them for like $9.99. So I definitely agree with this statement right here. Today, the cost of jeans varies greatly. The chart lists the price of jeans at several different stores. What are the median, least to greatest, middle, lower quartile, and upper quartile of the data? So I want the median of all the data. Then I want the lower quartile, which is the median of the lower part, and the upper quartile, which is the median of the upper part. So first I have to label them least to greatest. So find the median, the lower quartile, and the upper quartile. So step one, always, whenever you have a set of data, everyone listening, please number them least to greatest. Order them least to greatest. First thing you do. Whether you need to find the median or not, I think it's just easier if you order them least to greatest and know what you're dealing with. All right, circle the middle number or the median. Okay, so the median in this case would be 42. Let's just see. Left, right, left, right, left, right, left, right, middle. That means we have an odd set of data. So $42 is the median for all of the data. Step 3, calculate the upper and lower quartiles. Well, let's take a look here. The median of these numbers would be the lower quartile, and the median of these numbers would be the upper quartile. Okay, so calculate the upper and lower quartiles. Find the median of each half of the data set. Think, if a data set has an even number of values, the median is the mean of the two middle values, which we already know, but we're lucky because this set is odd. So remember, 42 was our median of the whole set. To find the lower quartile, we have to find the median of the lower half of the set of data. So we have 28 and 32, and we all know that the middle of 28 and 32 is 30. Or you could add it up and get 60, divide by 2, and get 30. So the lower quartile is $30. Whoops, they have that right here. Sorry about that. The upper quartile, left, right, we're left with two middles. Well, we know between 50 and 60, right, is 55. But if you would like to, you can add 50 and 60, get 110, and then divide that by 2, and you get 55. So some of the middles of the two you just know in common sense. Other times you have to add them together and divide by 2. So the median is 42. The lower quartile is 30, and the upper quartile is 55. Okay, this is not difficult. Order least to greatest, find your median. Then you have that separates the lower half from the upper half. Find the median of the lower half, that's your lower quartile. Find the median of your upper half, that's the upper quartile. Ready for your mind to be blown? Turn the page. A box plot. Here's how we're going to display the data so it's visually pleasing to our eye. I don't want to just look at a bunch of numbers. I'd much rather see a bar graph, a histogram, a dot plot, a box plot. So this is how we're going to show our data for the prices of the genes from the previous page. So a box plot is a type of graph that shows how data are distributed by using the least value, that's the lowest number, the lower quartile, which we found the median of that, of the lower group, the median of the whole set, the upper quartile, which is the median of the upper part of the data, and the greatest value. So the only thing we're adding to what we did on the other page is the least value and the greatest value. We already know the other 3. So there are 5 things you have to graph on a box plot. There are 5 dots or plots that you have to plot on a box plot. Okay, so we know that our lowest number in this set of data, if I go back to it, was 24, and the highest number is 75. Okay, so that's why 24 is graphed here, and 75 is graphed here. Makes a lot of sense. And then if we go back, let's see, our median we said was 42, lower quartile 30, upper 55. So we have 30 as our lower quartile median. 42 was our median of the whole set, and 55. Okay, 30, 42, 55. So 30 gets a dot, 42 gets a dot, and 55 gets a dot. Simple. So these 3 we just did on the previous page, but then you also have to extend your line off of the box to the lowest number and the highest number. Oh, now here's where this plot gets its name, box plot. You're going to draw a box including the lower quartile, around including the upper quartile, make the box, and then just put a line perpendicular through the median of the data, and you are done making your box plot. If you need to rewind that and watch it one more time because maybe, I don't know, a little brother or sister just ran in and screeched and then you lost your concentration, or you were just simply daydreaming about this beautiful week of weather we're going to have, I'm not sure, but rewind it so that you know what 5 dots you have to plot on your box plot. Okay, let's continue with the example of making a box plot. It says the data set below represents the ages of the top 10 finishers in the 5K race. Use the data to make a box plot. Very first thing you need to do is, say it out loud, order the data from least to greatest. Then find the median, which is the middle number of all the data when ordered least to greatest. Then find the lower, so you take the lower set, find the median, and the upper set, find the median. So if I were to order these least to greatest, I have 18, 19, 21, 23, 23, so 2 23s, 25, then we should have 30, 33, 35, 38. And I only know I have them all because they give us these nice blue lines right here. Otherwise, I'd have to count to make sure. Okay, so we need to find the median. So we lop off a left, right, left, right, left, right, left, right. Well, if I lop off the left, then I'll have to lop off the right. So these are my 2 middle numbers, and we can put them here, add them together, and divide by 2, or we should just know that 24 is the middle number between 23 and 25. So 24 is our median. Okay, now if we go back up here, remember our median is plotted on our box plot. So that's one of the 5 dots we need to plot on our box plot. the median of the whole set, so 24. Lower quartile, so we're going to take the lower quartile, remember, is the median of the lower half. Okay, so the lower half, now remember 24 is right here. So this is the lower half. Okay, so that's the lower half of the data. Oh, I don't know if I can, hold on. Let's go to blue. So 18, 23, 19, 23. So my median of the lower half is 21. That's the lower quartile. All right, let's pick red here. So remember, because this is our middle, this is our upper. You have to include the 25 in your upper, okay? So our median of the upper is 33, so the upper quartile is 33. So now we have 24, we have 24, ooh, I like that yellow, as our median. We have 21 as our lower quartile median and 33 as our upper quartile median. And then we just need the lowest value and the greatest value. Okay, well, our lowest value is 18 and our greatest value is 38. So we have to make sure that when we come down here for our number line, we are graphing 18 and it goes up here. I'll pick a different color. We have 18, okay, and then we have 38, 67, 38, and remember, this time for box plots, you graph above. Remember before I told you had to graph like right where the two lines cross? Not anymore, box plots are graphed above. Okay, and then we have our median, which is 24. We have our lower quartile, which is 21. We have our upper quartile, which is 33. Do we have our 5 dots plotted? Yes, we do. So remember, the median, which was 24, gets a line through it. Our lower quartile gets a line through it. Our upper quartile gets a line through it. You box them in, and then you reach out. I call those whiskers. Sometimes I think this was called a box and whiskers. Maybe I'm wrong. I'll have to look that up. So you whisker out to the highest and to the lowest, and there you have your box plot, the ages of the top 10 runners. It's really so much easier. I know it looks so intimidating. Okay, so then we just already did this. We drew a box from the lower to the upper. Inside the box, we drew a vertical line segment through the main median of the data. Then we drew out our whiskers from the box to the least and the greatest, and we are done. So basically what this is showing us is the variability of our data. Okay, it's a nice long box. That means our data must vary a little bit, right? If you had a shorter box, then your data is more concentrated toward the middle. And so the box is shorter because there's less numbers that are farther apart. All right, let's turn to the share and show. And what I would like you to do is just do number 1, and then we'll come back and look at it. So the scores of 11 students on a geography quiz are listed below. Oh, they've already ordered them for you. I'd like you to find the median and the lower quartile and the upper quartile, and also do the same for number 2. However, number 2, they didn't label them. They didn't order them for you. So number 2, you have to order them, then find the median, the lower quartile, the upper quartile. We'll come right back. So please pause the video. Okay, thanks for pausing. So your median of this data would be 86, the lower 78 median, and the upper median 90. And if you go to number 2, I ordered them up here because there wasn't enough room. Your median would be 51, lower quartile median 49, upper quartile median 61. Aren't we all grateful these aren't means? I mean, come on, right? Let's be thankful. All right, now number 3, let's make a box plot. So our lowest number is 46. Our highest is 65. Our median is 51. And that gets the line, right? As do, well, median is 51. Lower quartile is 49. Ooh, that's close. And 61 is the upper quartile, okay? So we box right around here. We have to put lines through the main median, the lower quartile, the upper, and then we extend the whiskers out. I really hope that's called a box and whisker. I should stop using that until I know. Anyhow, so that's our box and whisker plot. Okay.